Here I'm going to show you how to test drive your code. The technique I show here is simple, but learning the habit can be difficult to get used to. Pay close attention to the order in which I do things, as it may seem counterintuitive to anyone who has not developed the habit of test-driven design. The sample problem here is to sum up the times, hours and minutes, of a string like you see here labeled input. In this sample I have 12 minutes 32 seconds, 34 minutes 1 second, and so on. Afterwards, I expect to end up with the sum also expressed like the string you see here labeled expected, 2 hours, 32 minutes, and 41 seconds. I'm demonstrating test-driven design using Scala, but the concept works the same way in any programming language. Once you know what the goal is, a good way to get started is to assert the actual equals the expected. So here I type assert equals actual expected. Since I'm not using a test framework for this demonstration, I've already started with an implementation of assert equals. From what turned red, the compiler is telling me I need to define what actual is. One nice thing about statically typed languages is that the compiler can give you instant feedback. You can apply this same technique in dynamically typed languages as well, but you will have to wait until you run your tests to get your feedback. Something has to be in charge of computing actual, so let's give it the name string of times to some string and forward along the input. Notice that the main work I did here was coming up with a name string of times to some string. The habit to get into is a matter of what order you create the necessary parts of your application. I do not create something called string of times to some string until I'm sure I need it. The way I'm sure I need it is that my test would not run without a value for actual, so something has to be in charge of computing actual. It can be tempting to start with implementation details and put them together afterwards, and that is bottom-up design. What I'm teaching here is top-down design. Following what the compiler tells me I need, I define the function signature for string of times to some string. In Scala, triple question mark is a shortcut for throw new not implemented error. In other languages, you might have something like return null, return empty string, or simply an empty body. Now that everything compiles, I run the application and see that the test does not run. Instead, it throws a not implemented error. This guides me to what I have to do next, and this is where some intuitive yet bad habits are likely to manifest. The temptation is to think about details rather than design. But to make sure your design is top-down, you have to put off thinking about details to the last possible moment. The last possible moment is where the details are so trivial there is no other way to implement them. We are not there yet. Thinking about the highest level of design possible, it occurs to me that I can separate converting a string of times to the total number of seconds from converting a total number of seconds to a time represented as a string, leading me to this implementation. Notice the pattern here. I did not think of implementation details beyond my immediate need. This way, I am guaranteed that I am not writing anything I don't need. It is the primary mechanism by which I keep the code concise and easy to understand with no unnecessary complexity. I also do not mix detail levels in the same function. I write functions that can be expressed at a high level first, then delegate to functions at lower levels of detail. These lower level functions do not exist until after I prove I need them with a higher level function. Now the compiler is telling me I don't have implementations for string of times 2 seconds and seconds to some string. Notice another benefit here. I'm only concerning my mind with design decisions and naming, which are the parts most appropriate to human insight. What I am not doing is keeping track of where I am in this process, or what details are next, as I have the compiler and the test to do that for me. This division of labor makes software development much more effective, as the human can focus on things humans are good at, such as coming up with names, abstractions, and design, leaving the computer to unburden the cognitive load for things humans are bad at, such as keeping track of where I am. Relying on the compiler to tell me what I need to do next, I write the functions string of times 2 seconds and seconds to some string. Now I run the application and I'm guided to my next step, figuring out how many seconds I have in a string of times. I know I have to end up with seconds, so I start there. The input string already has many time strings, so I know I'm going to need to sum a sequence of them. I'm summing integers, which means each part is going to be converted into an integer, so I take care of that by mapping over a sequence to transform each string in the sequence to its corresponding seconds values, which tells me I'm going to need a way to go from a single time string to seconds. Finally, I'm ready for individual strings to be broken apart from the original input. Running the application again guides me to the time string to seconds function. So let's implement that. I need to end up with seconds, which I compute from minutes and seconds, which makes me realize I need to distinguish between seconds and total seconds. Minutes and seconds are going to be converted from strings. Which come from the parts of the individual time string. And I can get the parts by splitting on the colon. I run the application again to see where I'm at, and find out that I now need to convert from seconds to a sum string. Notice I had gone 2 levels deep to compute seconds, but did not get lost because running the test tells me what I need to do next. It is trivially easy for me to find out what I should be working on next. This is why top-down design is so much faster than bottom-up design. Between the compiler and tests, I am always guided to what to do next, and because I am strict about following the guide, there is no chance of me getting distracted by a detail I don't immediately need. With seconds to sum string, same as before, I start with what I need to end up with and let the compiler guide me from there. I need a sum string. I get a sum string from combining the strings for hours, minutes, and seconds, and then separating them with a colon. Hours and minutes come from their integer counterparts. Seconds is the same, but at this point I realize I need to distinguish between seconds and total seconds. I can get seconds from total seconds. Likewise, I can get minutes from total minutes. Which tells me I need total minutes. And finally, I can also get hours from total minutes. Now, by running the application, I realize I'm done. To be a little paranoid, let's check to see if the test is actually working. Yep, The test correctly identifies a mismatch between actual and expected, so let's change it back, and I am finished. In summary, you want to make sure every line of code you write is empirically driven. This starts with being test-driven, making sure your test matches the needs meant to be fulfilled by your application. It then goes a step further by making sure your design is top-down, which has the counterintuitive effect of the actual lines of code tending to be written from the bottom going up. This both speeds up your coding and simplifies the code itself, by ensuring you are not writing any code you don't need, and always have a guide keeping track of where you are, even if you end up going multiples of level detail deep in your implementation.